All right, this is another FRQ type question for AP. It says particle moves along a curve defined by this y equation here. The x coordinate of the particle x of t satisfies this velocity equation dx dt. That's the velocity in the horizontal direction for t greater than or equal to 0. The initial condition that at 0 the x coordinate is -4 applies. So they want us to find what is the x of t equation in terms of t. Well, in order to get this, we have this velocity equation we should be able to use in order to find x of t here. So x of t would be the antiderivative of our dx dt here, which is 1 over square root 2t plus 1. So if we find the antiderivative of that, that should give us the position function for the horizontal direction. So in order to do this one, how are we going to integrate this? To me, this one looks like a substitution one. So let's substitute 2t plus 1 in for substitute u in for that, which means derivative here is going to be 2 dt. So when we're substituting in for dt, it'll be 1/2 du. So making our substitutions now, this is going to become 1 over square root of u. Our dt here turns into 1/2 du. So to integrate, I'm just going to pull that constant out. I'm also going to write this as u to the -1/2. Now that's one I can do here, so you get 1/2. Antiderivative would be u to the +1/2. Reciprocal of that would be 2 over 1 plus some possible constant here. Now let's simplify. These cancel, so we're just going to get this to the 1/2. We also need to substitute back in though, so it'd be square root of 2t plus 1 plus some constant. That's our x of t equation. Now they want though, what is the exact one? So we have to figure out what is that c going to be. To do that, we're going to use that initial condition that it gave us up here, that x of 0 equals -4. So if we know that, if x of 0 equals -4, that means if we plug 0 in for t, we should be able to solve for the c now because x of 0 is -4. So as we solve here now, that is just square root of 1, which is 1. If we subtract that to the other side, that means our constant here is -5. So the final equation then for this one that we would write out as our answer is that x of t is equal to square root of 2t plus 1 minus 5. That's the equation they're looking for that one. All right, let's go on to part B. Find dy dt in terms of t. All right, so to find dy dt, what we want to do is look at what we have. So we have dx dt, that's given to us. We also have this equation for y here, which from that we should be able to, if we found the derivative, figure out what dy dx would be the derivative of that, which is 3x squared minus 3. Well, how can we use dy dx and dx dt to find dy dt? Use our derivative statement. So our derivative statement, we know dy dx is equal to dy dt over dx dt. That's our parametric derivative equation. So if we rearrange this to find dy dt, that means dy dt here would be equal to our dy dx times our dx dt. I just multiplied by our denominator there on what we had before. So let's fill in now what we know. dy dt, our dy dx we have over here, that's 3x squared minus 3. Our dx dt we have up there, that's 1 over square root 2t plus 1. So this is close to our answer, but we do have to make sure that, like they said here, that we find dy in terms of t. It's almost in terms of t. Part of this is in terms of t, but the other part's in terms of x. So how do we get to our final answer here? Well, we have to substitute in. We want to substitute in for x here to find that. How do we know what x equals? We just found that on the last part of this problem. X of t was equal to square root of 2t plus 1 minus 5. So using that, we're going to, from part A here, we know x is equal to square root of 2t plus 1 minus 5. So we're going to take that, substitute it in place here for x, and now we got our answer. So dy dt is going to be equal to, I'm going to make this into a fraction here. So it'd be 2t plus 1 on the bottom. On top, we're going to have 3 times what we're substituting in here, squared minus 3, and what we're substituting in is square root 2t plus 1 minus 5. And that would be our dy dt. All right, one last part to this FRQ. Part C wants us to find the location and speed of the particle at a time of 4. To do that, we are going to have to look at a few things here. One being that we can find our speed with that square root equation. So it'd be the square root of dx dt squared plus our dy dt squared. So our dx dt, we know that right here. We can substitute that in. Our dy dt from part B, we know. So from part B, we found that our dy dt equation comes out to be all this stuff here. Copy and paste all this. Now maybe I can't. So it would be that whole equation there. So what you want to do is type in, type this into the calculator to get the answer. So we know this from part B here. So in the calculator now, type all that in and find that out. So I'm going to pause it here and type that in so we're not wasting time on the thing. All right, so I've typed all this in here. We do want to make sure when we're doing this that we are inputting 4 for all the t's. So we're doing this dx dt here at t equals 4 squared. Same with our dy. Here, I'm going to write it a different method. So this would be our derivative of x at 4 squared plus our derivative at y at 4 squared. All right, so in the calculator here, you can see I've typed in our dx dt, and I've replaced the x with 4, and then here was our part B function we found, and again I replaced it with 4. So if we solve this, it looks like our speed equals about 3.018. And this would be in whatever the units are. They don't really mention units on this one. So that would be the speed of the particle. We do need the location as well. So the location, we need to find both the x and y value here. For the x value, we can use our equation again from part A. So we know that our x of t here equals square root of 2t plus 1 minus 5. So at 4, that's going to turn into 2 times 4 plus 1 minus 5. That's 8 plus 1 is 9. So you got square root of 9 minus 5, which is 3 minus 5, or negative 2. For our y value, we got this y equation up here that we can use, but that's in terms of x. But that's okay, because we just found what that x value was. It's going to be negative 2, so now we can solve this, the y value out, put negative 2 in for this, not 4, because 4 is the parameter of t. We want to put the negative 2 in here. So that's going to be negative 8 plus 6, which is also turns out to be, looks like negative 2. So the position at that, or the location is negative 2, negative 2. That's our location. So that would be the two answers for this problem.